Lesson 7.5, Indirect Measurement, Example 2. One of the places it's wonderful to go visit, and I love going there, is the Smithsonian Air and Space Museum in Washington, D.C. And at the Smithsonian there, they have rockets, actual rockets, that NASA has used. They have rockets from all over the world. Now, if you go there, these rockets are huge. And you kind of wonder sometimes exactly how tall are these rockets. But it would be very difficult, and there's signs all over the place saying, please do not climb. So it makes it a little difficult to actually climb up there with a measuring stick and figure out exactly how tall it is. But you could use indirect measurement. On a sunny day, let's say that you are standing by this rocket and it's casting a shadow. And that shadow goes out, and you could walk along that, and you could take a yardstick or a meter stick and measure out the distance, the length of that shadow. And let's say you do that, and you find out that the length of that shadow of that particular rocket is 91 5/10 feet, 91.5 feet. And we want to know the height of that rocket. Well, with one more side, if we pretend that there's a third side that comes down here, we have a right triangle. Now that in itself is not enough for us to figure out the height of the rocket, but there's a model rocket over to the side. And that model rocket, we do know the height of. And the height of that model rocket is 4 feet because it's small enough for us to actually measure. It's only about as tall. It's a little shorter than we are. And it casts a shadow of 3 feet. Well, if I know the height, again, if I could think of this as a triangle. And because it's also a right triangle, these are similar figures. That means we can use a proportion to determine our unknown height of the large rocket. So I'm going to compare our bases. And the base of the model rocket is 3 feet. 3 feet long. And the base of our large rocket is 91 5/10 feet long. So I'm comparing base to base. Now I can create a proportion from that. I can compare the heights as a ratio too. And I know that the height of my model rocket here is 4 feet. But what I don't know and what I'm trying to find out is the height of the rocket, h. So I can use this proportion to determine what the height of that rocket is. And with these numbers here, I'm going to use cross products. So I'm going to multiply 3 times our unknown h, and that will equal 91 5/10 times 4, multiplied by 4. So 3h will equal, and 91 5/10 multiplied by 4 is 366. Now I want to get h by itself, so I'm going to undo this multiplication. So I'm going to divide both sides by 3. And when I do that, h will come out to be 122. We're measuring in feet. That's 122 feet tall. That is the height of our rocket.